On the 5th of August, 1943, Hermann Göring stood frozen in his Berlin headquarters, clutching a reconnaissance photograph that would haunt German engineering for the remainder of the war. The Reichsmarshal's face drained of color as he stared at images of what appeared to be an entirely wooden aircraft, sleek, fast, and utterly impossible by everything his Luftwaffe engineers had told him about wooden construction. The British de Havilland Mosquito had just photobombed a German military installation at treetop level, and Göring's legendary composure shattered like glass. The wooden wonder had emerged from British ingenuity, born of desperation. When Geoffrey de Havilland first proposed his radical design in 1938, the Air Ministry dismissed it as fantasy. Metal was king, they insisted. Steel and aluminum represented modernity and strength. Wood belonged to the primitive biplanes of the Great War, not to the sleek fighters that would dominate the coming conflict. But de Havilland saw what others could not. A vision of laminated birch plywood formed into compound curves, creating a structure stronger than its weight suggested possible, invisible to the primitive radar systems beginning to dot the European coastline. The Mosquito's development accelerated as the Battle of Britain consumed Britain's aluminum reserves. Furniture makers and piano craftsmen found themselves conscripted into aircraft production, their skills with wood veneer suddenly more valuable than any engineering degree. The de Havilland factory at Hatfield hummed with the smell of Canadian birch and Ecuadorian balsa, layers of wood pressed together with casein adhesive derived from milk protein. These craftsmen built aircraft the way their ancestors had built ships, by feel, by tradition, by an intimate understanding of how wood breathed and flexed and bore stress. According to historical records maintained by the Royal Air Force Museum in London, the first operational Mosquito took flight in November 1941, and within months, it proved faster than the Luftwaffe's frontline fighters. This context comes from aviation historian Martin Bowman's extensive research on the Mosquito's operational history, which documented how the wooden bomber could outrun German interceptors while carrying a substantial bomb load deep into Reich territory. Göring's rage at the Mosquito's success became legendary among Luftwaffe personnel. He had promised Hitler air superiority, yet these wooden relics, built by furniture makers no less, penetrated German airspace with impunity. The Mosquito carried no defensive armament, relying entirely on speed to survive. It mocked everything the Luftwaffe had built, every Messerschmitt and Focke-Wulf that burned precious fuel chasing shadows. German pilots reported engagements where the Mosquito simply accelerated away from their fighters, disappearing into clouds before they could bring guns to bear. The psychological impact cut deeper than military losses. Germany prided itself on technological superiority, on precision engineering and industrial might. The Third Reich's propaganda machine had convinced the world, and themselves, that German manufacturing represented the pinnacle of modern warfare. Yet here came the British with their wooden aeroplanes, assembled in furniture factories by craftsmen who had been making chairs and tables before the war, utterly dominating the night skies over Europe. Göring's obsession with copying the Mosquito would consume German resources and engineering talent for years, becoming a case study in how envy drives poor strategic decisions. The morning of January 15, 1942, brought Geoffrey de Havilland to the Salisbury Hall facility, where his team had achieved what many considered aeronautical alchemy. The prototype sat gleaming in the hangar, its smooth wooden skin reflecting light like polished furniture. De Havilland ran his hand along the fuselage, feeling the subtle texture of the birch plywood beneath layers of dope and paint. This was not merely an aircraft, it was a revolution wrapped in tradition, a marriage of medieval craftsmanship and modern aerodynamics. The construction technique defied conventional wisdom at every turn. The fuselage consisted of 2 hollow shells built over concrete molds, each shell comprising 7 layers of birch veneer laid at alternating angles. The workers applied each layer by hand, brushing on adhesive and carefully positioning the wood strips to avoid weak points. Once both shells cured, they joined them together with a balsa core sandwiched between, creating a monocoque structure that distributed stress across the entire airframe. No internal framework, no heavy stringers or formers, just wood, glue, and geometry. Canadian yellow birch provided the outer skins, its tight grain and natural strength perfect for bearing aerodynamic loads. Ecuadorian balsa, despite its lightness, possessed remarkable compression resistance and served as the core material. Douglas fir reinforced high-stress areas like wing roots and tail attachments. The British had scoured their empire for these materials, establishing supply chains that stretched across oceans to feed the mosquito production line. Piano manufacturers contributed their expertise in wood bending, furniture makers brought their knowledge of joinery, and boat builders understood how to seal wood against moisture penetration. Speed emerged as the mosquito's defining characteristic. The prototype exceeded 400 miles per hour in level flight, faster than any bomber then operational and competitive with contemporary fighters. This velocity came from the combination of two Rolls-Royce Merlin engines, the same power plants driving Spitfires and Hurricanes, and an airframe with remarkably low drag. The wooden construction allowed for smoother surfaces than riveted aluminum, reducing turbulence. The compound curves possible with laminated wood created more aerodynamic shapes than could be achieved with metal panels bent around formers. British pilots who flew the Mosquito spoke of it with reverence bordering on worship. Flight Lieutenant John Cunningham, who became one of the type's most celebrated operators, described his first flight in March 1942 as transcendent. The aircraft responded to control inputs with a precision that suggested a direct connection between pilot thought and aircraft movement. It climbed rapidly, maneuvered like a fighter despite its size, and possessed a top speed that provided the ultimate defense, the ability to simply run away from any threat. The versatility surprised even de Havilland himself. The basic airframe adapted to multiple roles with minimal modification. Fighter bombers carried bombs internally and guns in the nose. Photo reconnaissance variants flew unarmed at extreme altitudes, their crews relying solely on speed and height for protection. Night fighters mounted radar and heavy cannon, stalking German bombers over England. Pathfinder versions marked targets for the main bomber streams. Each variant exploited the wooden construction's flexibility, the ease with which craftsmen could modify jigs and molds to accommodate different equipment. On September 23, 1943, Luftwaffe General Adolf Galland sat in his office reviewing combat reports that painted an increasingly desperate picture. Mosquito incursions had increased exponentially over the previous months. The wooden aircraft penetrated German airspace at will, photographing military installations, dropping precision bombs on factories, and generally demonstrating that the Reich's vaunted air defense network had been rendered obsolete by British carpenters. Galland, one of Germany's most respected fighter aces, found himself unable to offer his superiors any solution to this humiliating problem. The Mosquito raids cut deeper than their material damage suggested. Berlin itself had become a regular target for small formations of the wooden bombers, which arrived at high altitude during daylight hours or at low level during darkness. The psychological impact on the German population proved devastating. If the Luftwaffe could not protect the capital from wooden aeroplanes, what hope remained for victory? The propaganda ministry scrambled to explain away the raids, but citizens could hear the explosions and see the smoke rising from bombed buildings. German technical intelligence worked desperately to understand the Mosquito's secrets. Shot-down examples were rare. The aircraft's speed meant most damaged Mosquitoes either reached friendly territory or disintegrated completely in crashes. When fragments were recovered, German engineers examined them with confusion bordering on disbelief. The construction quality exceeded anything they had thought possible with wood. The layered plywood showed no signs of delamination, even after exposure to combat stresses. The adhesives maintained their integrity despite temperature extremes and moisture. How had the British achieved this with such primitive materials? Luftwaffe intelligence services mounted operations specifically targeting Mosquito production facilities and development records. Agents in Britain reported back fragmentary information about the de Havilland factories, about the furniture manufacturers contributing components, about the specialized glues and wood treatments. But knowing the ingredients did not provide the recipe. The British had developed institutional knowledge over years of production, solving hundreds of small problems through trial and error. German engineers reading stolen specifications faced the impossible task of recreating that accumulated wisdom from scratch. The contrast with Germany's own aviation industry could not have been starker. German aircraft manufacturers relied on aluminum alloys and skilled metal workers, both of which were becoming increasingly scarce as the war consumed resources. The Luftwaffe's production rates stagnated while Allied bombing disrupted supply chains. Meanwhile, Britain produced mosquitoes in workshops scattered across the countryside, facilities that required no specialized equipment beyond woodworking tools and curing ovens. The furniture factories continued making aircraft even as German bombs fell on major industrial centers. Göring's frustration manifested in increasingly erratic behavior. He demanded that German industry produce a wooden aircraft superior to the Mosquito, despite having no expertise in such construction. He berated engineers for their failure to copy what British furniture makers had achieved. His public statements grew divorced from reality, claiming German fighters were shooting down mosquitoes in large numbers when combat reports showed the opposite. The gap between propaganda and truth widened into a chasm that swallowed German credibility. On November 8, 1943, Willy Messerschmitt received orders that filled him with dread. The Reich Air Ministry demanded that his company develop a wooden aircraft matching the Mosquito's performance within 6 months. Messerschmitt knew immediately that the timeline was fantasy, but refusing orders from Göring's ministry invited consequences worse than failure. The Messerschmitt 308 project began under a cloud of impossible expectations and inadequate resources. German industry possessed no institutional knowledge of wooden aircraft construction on the scale required. The last German wooden bombers had been built in the Great War, a quarter-century earlier. Most craftsmen with relevant skills had retired or died. The younger generation of aircraft workers knew only metal, how to rivet aluminum sheets, how to form steel tubing, how to weld magnesium alloys. Wood remained the province of furniture makers and carpenters, and none of them understood aircraft structural requirements. The 308's design emerged as a crude amalgamation of Mosquito features, grafted onto German engineering preferences. Messerschmitt's team created a twin-engine aircraft with wooden wings and fuselage, but they could not replicate the elegant compound curves of the British original. German engineers thought in straight lines and simple angles, the geometry of metal fabrication. The subtle aerodynamics that made the Mosquito so efficient eluded them. Their wooden prototype looked like exactly what it was, a metal aircraft awkwardly translated into wood. Material shortages plagued the project from its inception. Germany lacked access to Canadian birch and Ecuadorian balsa. Domestic alternatives proved inferior. German beech was heavier and more prone to splitting than Canadian birch. European spruce could not match balsa's strength-to-weight ratio. The adhesives available to German manufacturers came from synthetic chemistry rather than natural sources, and they behaved differently under stress and temperature variation. Every material substitution introduced new problems that cascaded through the design. The first 308 prototype emerged from the Messerschmitt factory in April 1944, 5 months behind schedule and drastically overweight. Test pilots reported that it handled like a truck compared to the nimble Mosquito. The wooden construction creaked and groaned during maneuvers, suggesting structural problems. Maximum speed barely exceeded 350 miles per hour, far short of the Mosquito's 400 plus. The aircraft was obsolete before it flew, outperformed by the very enemy it sought to copy. Production difficulties multiplied as Messerschmitt attempted to manufacture the 308 in quantity. The skilled craftsmen needed for wooden construction simply did not exist in sufficient numbers. Training programs took months to produce workers with basic competency, and even trained workers struggled with the exacting tolerances required. Quality control became a nightmare. Delamination appeared in wings during stress testing. Adhesive joints failed unpredictably. Moisture absorption caused warping in completed assemblies. By August 1944, the Reich Air Ministry quietly canceled the 308 project after producing fewer than 50 aircraft. Most never saw combat. Those that did proved vulnerable to Allied fighters, lacking the speed that made the Mosquito untouchable. German pilots hated the 308, considering it a death trap that combined the worst characteristics of wood and modern aircraft. The project had consumed thousands of work hours and precious materials while producing nothing of military value. Göring's obsession with Copying the British wooden wonder had resulted in Germany's most embarrassing aviation failure of the entire war. On June 6, 1944, as Allied forces stormed the beaches of Normandy, mosquitoes flew overhead providing reconnaissance and close air support. The wooden aircraft had become ubiquitous in the British war effort, serving in roles its designers never anticipated. From marking targets for Lancaster bombers to hunting German submarines in the Atlantic, the Mosquito proved that the British had not merely built a good aircraft. They had created a masterpiece that redefined what wood construction could achieve. The production numbers told a story of industrial triumph. De Havilland factories across Britain and Canada produced over 7,500 Mosquitoes during the war years, an average of nearly 6 aircraft per day at peak production. This output dwarfed German efforts to create wooden aircraft alternatives. The distributed manufacturing network meant that no single bombing raid could significantly disrupt Mosquito production. While German aluminum aircraft factories burned under Allied bombing campaigns, British furniture workshops continued churning out wooden warriors. Mosquito crews developed tactics exploiting their aircraft's unique capabilities. Low-level precision bombing missions became a specialty, with Mosquitoes racing across occupied Europe at treetop height to strike specific buildings with delayed fuse bombs. The famous raid on Amiens prison in February 1944 demonstrated the type's precision. Mosquitoes breached the prison walls, allowing French resistance members to escape, while avoiding the prisoner housing blocks. Such surgical strikes required not just skilled pilots, but an aircraft responsive and fast enough to navigate obstacle-filled terrain at high speed. The night intruder role proved particularly devastating for German forces. Mosquito night fighters patrolled German airspace, ambushing Luftwaffe bombers and transports. Equipped with airborne radar and heavy cannon, these wooden predators hunted in the darkness, their wooden construction making them difficult for German radar to track. Luftwaffe crews learned to fear the distinctive sound of Merlin engines overhead, knowing that a Mosquito could appear without warning and disappear just as quickly. Photo reconnaissance Mosquitoes provided Allied intelligence with unprecedented insight into German military capabilities. Flying at altitudes approaching 40,000 feet, these unarmed aircraft photographed everything from V-weapon sites to submarine pens. Their speed and altitude made interception nearly impossible. German anti-aircraft batteries fired futilely at contrails, while Mosquito cameras captured images that would guide bombing missions and invasion planning. The intelligence gathered by these wooden scouts proved invaluable for Allied strategic planning. The psychological impact on German morale cannot be overstated. Every Mosquito that penetrated Reich airspace unchallenged demonstrated Allied technological and industrial superiority. German citizens hiding in shelters during air raids knew that even wooden British airplanes could reach them with impunity. The propaganda value worked both ways. While Britain celebrated the Mosquito as proof of innovative excellence, Germany struggled to explain how their modern metal fighters could not catch what they dismissively called plywood bombers. Technical innovations continued throughout the Mosquito's service life. Later variants featured pressurized cockpits for high-altitude reconnaissance, improved engines pushing speed beyond 430 miles per hour, and sophisticated electronic warfare equipment. The wooden construction adapted easily to these modifications, craftsmen simply altering molds and jigs to accommodate new requirements. This flexibility stood in stark contrast to metal aircraft designs, where structural changes often required extensive retooling. On October 12, 1944, American aviation engineers arrived at de Havilland's Hatfield facility to study the Mosquito production process. The United States Army Air Forces had considered licensing the design for American production, but wanted to understand exactly what made the aircraft so successful. What they discovered was not a single revolutionary innovation, but rather a symphony of small refinements, each contributing to the whole, each dependent on skills that could not be easily transferred or replicated. The wood selection process began the journey from raw material to combat aircraft. Inspectors examined every board of birch, rejecting pieces with grain irregularities, knots, or signs of disease. Only the finest examples passed muster, ensuring that the finished aircraft's structural integrity would not be compromised by material defects. This attention to detail required experienced eyes, craftsmen who understood wood as a living material with individual characteristics. German manufacturers, attempting to rush production, lacked this discriminating selection process. The adhesive formula represented years of chemical engineering refinement. British scientists had developed a casein-based glue that remained flexible across temperature extremes, resisted moisture penetration, and actually increased in strength over time as it cured. The formula included additives that prevented fungal growth and insect infestation, critical for aircraft operating in diverse climates. German chemists, working with synthetic alternatives derived from coal tar, could not match these properties. Their adhesives either became brittle in cold weather or softened in heat. The curing process demanded precise environmental control. Completed fuselage shells spent days in heated chambers where temperature and humidity were carefully regulated to ensure proper adhesive cure. The concrete molds used to shape the fuselage sections maintained dimensional accuracy despite repeated use. British quality control inspectors checked every joint, every bond line, using techniques adapted from piano manufacturing where similar precision was required. German factories, under pressure to increase production rates, often shortened curing times or skipped inspection steps, resulting in structural failures. Wing construction illustrated the sophistication of the Mosquito's engineering. The wing consisted of a single-piece main spar made from spruce, with plywood covering forming the aerodynamic shape and bearing torsional loads. The integration of these elements created a structure that distributed stress evenly, preventing the concentration of forces that led to failure. German engineers, accustomed to metal wing structures with discrete ribs and spars, struggled to replicate this holistic approach. Their wooden wings tended to fail at junction points where different components met. The American engineers documented everything, filling notebooks with sketches and specifications. But even as they wrote, they understood that capturing the knowledge proved easier than applying it. The British had developed their techniques through thousands of hours of production experience, solving problems as they arose, gradually refining processes until everything worked harmoniously. Transferring that accumulated wisdom to American factories would take years of trial and error, years the war might not allow. Surface finishing made the difference between adequate and exceptional performance. British workers applied multiple coats of aircraft dope, sanding between layers to achieve a mirror-smooth finish. This attention to surface quality reduced drag by preventing boundary layer separation. German 308 examples showed rougher surfaces, the wood grain visible through inadequate finishing. In high-speed flight, these small imperfections cost performance, contributing to the type's inferior speed compared to the Mosquito. On February 14, 1945, as Allied armies pressed into Germany from all sides, Albert Speer sat in his Berlin office reviewing production statistics that illustrated the Third Reich's aviation industry collapse. Among the sobering numbers, one comparison particularly stung. British wooden Mosquito production had exceeded German frontline fighter production for 3 consecutive months. The furniture makers had outbuilt the industrial might of the Reich, and Speer understood that this embarrassment symbolized Germany's strategic defeat. The Mosquito's success vindicated an approach to warfare that Nazi ideology rejected: pragmatism over dogma. The British had embraced wood construction not because it was ideologically pure or technologically advanced, but because it worked. They utilized available resources efficiently, mobilized civilian craftsmen, and accepted an aircraft design that looked backward to succeed forward. Germany's insistence on metal construction reflected a broader rigidity that hamstrung their war effort. When ideology trumped practicality, defeat became inevitable. The economic calculus heavily favored the Mosquito. Each aircraft required approximately 15,000 man-hours to produce, significantly less than metal bombers of comparable capability. The distributed production network eliminated bottlenecks and reduced vulnerability to disruption. Materials costs remained low. Wood was renewable, abundant, and required minimal processing compared to aluminum alloys. Britain effectively converted forests into air power, a transmutation Germany could not match despite controlling vast timber resources in occupied territories. Strategic bombing analysis revealed that Mosquitoes achieved disproportionate impact relative to their numbers. While Lancaster and Halifax heavy bombers delivered the bulk of bomb tonnage, Mosquitoes struck high-value targets with precision that mass formations could not match. The famous Shellhus raid in Copenhagen on March 21, 1945, exemplified this capability. Mosquitoes destroyed Gestapo headquarters, with minimal civilian casualties in a daring, low-level attack. Such missions enhanced Bomber Command's reputation and demonstrated that precision could sometimes accomplish what mass could not. The fighter-bomber variants particularly troubled German military planners. Mosquitoes roamed over German territory at will, attacking trains, trucks, command posts, and concentrations of troops. Their speed made them nearly invulnerable to interception, and their wooden construction defeated proximity-fused anti-aircraft shells that were designed to detonate near metal aircraft. German ground forces learned to fear the sudden appearance of Mosquito fighter bombers, which struck without warning and disappeared before defensive fire could be organized. The night fighter variants effectively ended the Luftwaffe's bombing campaign against Britain. By late 1944, German bomber losses to Mosquito night fighters had become unsustainable. The wooden aircraft, invisible to German early warning systems, lurked in darkness waiting for their prey. British air defense had evolved from the desperate scrambles of the Battle of Britain to a sophisticated system where Mosquitoes hunted German bombers with impunity. The hunter had become the hunted, and the reversal was complete. Intelligence operations benefited enormously from Mosquito reconnaissance capabilities. Photo interpreters worked with images so detailed that individual vehicles could be identified, fortifications precisely mapped, and troop movements tracked. This intelligence guided Allied strategy, allowing commanders to plan operations with unprecedented knowledge of enemy dispositions. The Germans attempted similar reconnaissance, but their aircraft lacked the Mosquito's combination of speed, altitude capability, and range. On May 8, 1945, as Germany surrendered unconditionally, Hermann Göring sat in Allied custody, his Luftwaffe destroyed, and his reputation in ruins. When interrogators questioned him about German aviation failures, the subject of the Mosquito arose repeatedly. Göring's responses revealed a man who had never truly understood why Britain's wooden wonder had succeeded, while Germany's attempts to copy it had failed so spectacularly. The technical details eluded him, but the humiliation remained vivid and bitter. The post-war analysis by Allied technical intelligence teams painted a comprehensive picture of German failure. Teams examining captured Messerschmitt. 308 examples found evidence of rushed construction, inadequate materials, and fundamental misunderstanding of wooden aircraft engineering. German engineers had approached the problem as if wood were simply a substitute for metal, rather than a completely different material requiring different design philosophies. This conceptual error doomed the project before construction began. The Mosquito continued service long after Germany's defeat, flying with air forces around the world into the 1950s. Its longevity testified to the soundness of its design and construction. While metal aircraft of its era quickly became obsolete, the Mosquito adapted to new roles, proving that good engineering transcends the materials used. The wooden wonder had outlasted the metal machines built to destroy it, an ironic victory that would have pleased Geoffrey de Havilland immensely. The contrast between British success and German failure illustrated fundamental differences in how the two nations approached industrial challenges. Britain embraced distributed production, civilian expertise, and pragmatic solutions to material shortages. Germany remained wedded to centralized control, military hierarchies, and ideological purity over practical effectiveness. The Mosquito versus 308 comparison became a case study in how organizational culture impacts technological achievement. Aviation historians examining the Mosquito phenomenon identified several factors contributing to its success that Germany could not replicate. Britain's furniture industry provided a ready workforce with transferable skills. The empire's global reach ensured access to optimal materials. Years of commercial aircraft production had taught de Havilland valuable lessons about wood construction. Most importantly, British culture embraced incremental innovation and practical experimentation, while German culture favored theoretical perfection and top-down planning. The wooden aircraft debate continued in aviation circles for decades. Some engineers argued that the mosquito represented a technological dead end, a brilliant solution to a temporary problem that would inevitably be superseded by metal and later composite construction. Others saw it as proof that the best solution depends on available resources and specific requirements, rather than abstract notions of technological advancement. The Mosquito had been the right aircraft at the right time, built by the right people with the right skills. Geoffrey de Havilland lived to see his creation recognized as one of the war's most significant aircraft. He remained modest about his achievement, typically British in deflecting praise to his team and the craftsmen who built the Mosquitoes. But privately, he must have savored the knowledge that his wooden wonder had driven Göring to distraction, had humiliated German engineering, and had proved that innovation sometimes means looking backward to move forward. The furniture factories had defeated the industrial might of the Reich, and in that victory lay a lesson about hubris, adaptability, and the true nature of engineering excellence that echoed long after the last Mosquito left service.